Um, all these red numbers that you see in these boxes, these cubes, these are the additions of, such as like 1 for all these faces of this side of the cube, um, 2 for the back sides of the cubes, 3 for the top sides, 3 for the top sides, 4 for these back sides, 5s for the front sides here, and 6s for the bottoms. That's how I usually label them. And the red numbers are the addition of each of these blue numbers into these cubes. And here it is up here. 1s all over the faces of these cubes. 2s all over the faces of these cubes. 3s all over the faces of these cubes on top. 4 on the faces of these cubes. 5s on the faces of these sides. And 6s on the bottom that you can't see that. And the red numbers that you see, the red numbers are the addition of every number that intersects the cube. Every blue number, 1, 5, and 3, for example, is 9. 3 is 9. And it goes the same way with the edges. 1 and 5 is 6. And faces. 1, there's nothing that intersects it. So it's 1. And this is a synergetic fractal cube. It tells you how many hidden faces there are by adding up these numbers, not just once. These red numbers, not just once, but 3 times for the corners, 4 times for the edges, 5 times for the faces. And these red numbers by themselves tells you how many faces there are when you add all of them up all together. When you add them all up, that's what all this is. And it puts out a number. 714. The central number 21, which is the addition of the 1, 2, 3, 4, 5, 6, 21, divides into it 714 times, which gives you 34. There's 25 faces out here. 5, 10, 15, 20, 25, and 9 faces on this inner cube. Well, the synergetic part of it, you add up how many hidden faces there are, and it gives you a total for the outside, 105, 2,205. 21 divides into it 105 times. There's 105 if you count 3, 3, 3, 3, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 1, 5, 5, 5, 5, 5, 5, 5, 5, 5 for the faces. It tells you how many on the outer side. For the inner cube, you can add up these numbers separately. There's for a grand total when you add them all together, 138. There's 33 faces, 3 times plus 3 faces, 3 faces, 3 faces, 3 faces, 4 faces, 4 faces, 4 faces, 4 faces, and 5 faces. That's 33 combined with 105 of the outer cube, the outer shell. And that's what this represents, a synergetic cube, synergetic fractal cube. And it tells you how many locked up hidden faces there are, not only on the outer shell cube, but also on the 3 by 3 by 3 inner cube that spans this sheet right here. The outer cube fractal cube is a 5 by 5 by 5, and the inner cube is a 3 by 3 by 3. And when you add those together, it tells you how many hidden faces there are. And I think of it synergistically as a hidden faces. So the normal fractal number 714 tells you how many faces there are. When you divide by 21, 34, there's 25 on the outside cube, 9 on the inside, which is total of 34. Well, the synergetic numbers tells you how many hidden faces there are of the outer cube, and 33 for the inner cube, for a total of 138 hidden faces per outer cube and inner cube. And since you can't separate the inner cube, it tells me that it doesn't really have any outside. It's not really the interior of this cube, it's its own interior. In a way, it has its own interior, because you're not using the same. If you were using the same method to find the outer cube, you would have to include 6 faces hidden on these, but you don't add them up that way. You add them up the same you do as the outer ones. 3 faces hidden on the corners, 4 faces hidden on the edges, 5 faces hidden on the face cubes. So it tells me that this cube is not really the interior of this cube, even though we call them nested. They're not actually the interior of this cube. So that's the thing to take away from this, is that the inner cube is not really nested. We call it nested, but if you follow the same rules that you do for the outer cube, then all these cubes would have to count 6 faces hidden on all of them. But they follow the rules as if it was just the cube itself, the central 9 by 9, or the inner 3 by 3 by 3 cube. If I explained that as good as I could. So here's one last image of this. These are the cube numbers 3. There's 1, 2, 3. There's 5 where the 2 and 3 intersect. There's where the 5, 3, and 4 intersect. There's 12. So if you get the picture of this, that's about it. Thanks a lot.